Hi STEAM makers, welcome back to the Maker STEAM Club. I'm Godiva and today we're going to be building a sound and light circuit with toggle switches. So far we've explored series, parallel circuits, but also electricity. We've also talked about active and passive components. Today, we're going to be introducing another active component, and that is our active buzzer. So, for this sort of circuit, for sound and light, we'll be using these components. Our breadboard, 3 tactile switches, 3 1K ohm resistor, 3 LEDs, 1 active buzzer, 3 green wires, 3 red wires, a black wire for ground, and of course, our power pack. Now, let's start making. Firstly, we'll take our active buzzer and insert into lines 28, 29, and 30 on our breadboard. Now, we'll start to connect our switches. We're going to be taking our first switch, connecting it right at the top here in line 1. Our next switch we will be connecting down at line 4, and our last switch will be connecting all the way down at line 7. Perfect. As always, we know that before we put in an LED, we have to have a resistor. So let's start connecting our resistors. Now we have our buzzer in, our 3 tactile switches, and our 3 resistors. What do you think we're going to do next? That's right, we're going to be connecting our 3 LEDs. So we've been using RGB, so we're going to use that order just the same now. First, let's put in our red LED. And always remember, the longer leg is the positive lead. So first, we have to identify the longer leg on our red LED. And here we are. And lastly, we put in our blue LED. Always checking the longer leg is the positive lead, and our longer leg is going to be where we're going to be connecting our positive rail. Now, this is where we're going to be using our 3 green wires. First, we're going to be taking the negative lead off our red LED and connecting to where we'll be having the positive leg off our buzzer. So, because this is a parallel circuit, there needs to be a common point, and the common point is going to be this leg that is shared by all 3 LEDs. So all our green wires are going to be in the same line, and in our case, that's line 24. So now we have all our components connected on our breadboard. We have our 3 tactile switches, 3 1K ohm resistors, 3 LEDs, and our wires that lead to our active buzzer. Now for the final step, we'll be connecting our active buzzer to ground, and we are going to be connecting our 3 tactile switches to power from line 1, line 4, and line 7. Okay, there we have our light and sound circuit. Last but not least, we have to plug in our battery pack. By convention, we're using red as the positive lead and black is our negative lead. Stupid buzzers. So, after all that tinkering, we finally found out what our problem was. So, earlier in the video, we actually mentioned that we were using 1K ohm resistors. 3 1K ohm resistor, 3 1K ohm resistor it turns out that when we try to use our 1K ohm resistor, some of our components would light up, but the buzzer would never go off. So we fixed the problem. After a lot of troubleshooting, we ended up realizing that what we needed wasn't a 1K ohm resistor, but just a 10K ohm resistor. So let's now try to make these all light up, and I'll show to you that what was missing was just a smaller resistance. So here we have our red, green, got it, and our blue. Now that we've completed our sound and light circuit on our breadboard, we can actually start playing around with it. But if we wanted to have this same circuit in a more orderly fashion, we would put it on a PCB, just like this one. PCB actually stands for printed circuit board, and here we have a double-sided printed circuit board where we have holes drilled on the top as well as holes drilled on the bottom. Each of these holes allow for metal components and electrical components to be connected as long as we use our solder station and our solder wire. So let's get started moving our components from our breadboard to our PCB. We're moving these things from one place to another, moving them from one place to another. So we've taken off our tactile switch from our breadboard, put it onto our PCB, and it's time to solder. Ensure that your soldering station is actually put to the max, and ensure that we're also in a very well ventilated space. Soldering can be a little toxic, but as long as we ensure that we follow these safety rules, we should be fine. Now that we have our soldering iron ready and we have our solder wire, it's important to know that when you're soldering, you're actually not heating up the wire. You're heating up the leads of the component or the iron or metal around the holes that are drilled here. So we'll simply go ahead by heating up each hole, and once the hole is properly heated, we'll go ahead and tap our solder wire onto the holes. Woo! Look at that! There we have our components being soldered onto our PCB. Now, you'll realize that they're securely placed. So, we now have 2 components on our board with just about 12 to go. This may take a while, so let's speed this up. So we're just about finished. Now we still have our LEDs to remove and put on our PCB. So let's speed the process up again. There we have it. We're all done. Now we have all of our components on our PCB. But guess what? If we try to connect this right now, nothing will turn on. So we have a little bit more work to do, but it's important that we know that anything that you do on a breadboard can be transferred to a PCB, and we will use a bit of our soldering skills to get that done. Now, let's start to explore in our next session just how we can take this very simple circuit to turn it into just about anything that we want. One of the things that we'll be creating is a simple ABC toy, and you can use it to do your own busy boards.